tell me, because I've had a couple of other Algebra 2 students, and they weren't certain what your general format that is being taught to you for a parabola. And here's the two choices. This is the basic choice for parabolas that are at the origin. But when you start talking about parabolas as conic sections, this is the format. With P,
Yeah.
the distance to the focus. Can you tell me, is this second one look familiar to you?
Yeah.
Okay, good. I was 90% sure that Chatfield taught this format here.
Well, I use them both often.
Yeah, well, all this means is that A is equal to 1 over 4P, or if you like, P is equal to 1 over 4A. Okay?
Yeah.
So you can kind of handle either format. It's just that this is more standard. I'm not quite sure why. I would think that once they had taught people this format, they would want to stick with it. But that doesn't seem to be what they do. Like I said, I'm not sure that as soon as you get into conic sections, they switch the general format to this, and I don't really know why, other than when you used to deal with quadratics, parabolas, you didn't worry about P or the Directrix, right?
Yeah.
But now that they are asking you and letting you know about this thing called the focus and the Directrix, so let me give you a quick example here. If I said 8y equals x squared, we know that's a parabola like that with its vertex at the origin.
Yeah.
What's P?
P is the
The distance from the vertex to the focus. In this case, what's P? If this is true, what's P equal to?
2.
Yeah. In other words, what you do is once you get your equation in the format of the general format, then you just equate 4P to whatever that coefficient of the y term is. If the y term was 4, P would be 1. If the y term was 12, the coefficient, then P would be 3. So
Okay.
there's one advantage in this new format, and that is it makes it a little quicker to figure out what P is. Well, if the coordinates are on P are 0, 2, which they are, where's the directrix? What's the equation of the directrix?
-2.
Okay, remember one very important thing, that is a line. So we need an equation of a line. What's
X equals -2.
It's not x, it's y equals -2. Remember, horizontal lines are y equals. In other words, no matter what x is, y is -2, correct?
Yeah.
Okay. Now, the one last thing they care about is the axis of symmetry, which is the axis that goes vertically through the parabola, or you now have to deal with horizontal parabolas also. What's the equation of that line?
Of the axis?
Of the axis of symmetry.
0.
Again, it's an equation of a line.
X equals 0.
X equals 0. Whenever you have vertical lines, it's x equal some number. When you have horizontal lines, it's y equals some number. Now, there's one additional twist that here's the parabolas you've been dealing with for 3 years, right? And we know that those are either vertical like that, or if there's a negative sign in front of the x squared term, then they open down like that, right?
Yeah.
Well, if you make one little change and make it x equal y squared instead of y equal x squared, this becomes a horizontal parabola that opens to the right. And if I make it x equal negative y squared, it's a horizontal parabola that opens to the left. So
I had known
horizontal,
that, but I had some pretty specific questions for vertex, intercept, and standard form, graphing those.
perfect. Shoot them to me.
I think I already sent you an email with the pictures for the questions, but.
Okay, let me have a quick look. I hadn't seen it when we started the session. Maybe it's here by now. Yeah, there it is. Which attachment do you want to start with?
Let's start with the bottom left one.
Okay. Formulas to memorize. Well, notice that the general formula, they're still using the old one, the Vertex Formula.
Mm-hmm.
And then they tell you that A is basically 1 over 4p. In other words, the only difference between this format and this format, if you're at the origin for your vertex, is instead of A, they've replaced it with 1 over 4p. But I don't see anywhere on here where they actually state the general format using the 4p, like in this. In other words, if I were to take that vertex format, which is y, hold on, we got y equals a times x minus h squared plus k. That's the format for any parabola that opens up or down. Okay? But if I want to turn it into this format using the p, the first thing I do is I move the k over. So it becomes y minus k. That's equal, and a we know is 1 over 4p. And that's x minus h squared. Now multiply both sides by 4p and you end up with this. And that is the general format. Hold on a minute, let me quiet my dogs down. That is the general format for the parabola that is not at the origin, where the vertex would be h and k. But notice the difference. There's a little bit of difference. You move the k over, first of all, and then you turn the a into 1 over 4p, and then you move the 4p over. The way I kind of memorize this, as the 4p goes in front of the variable that is not being squared. And likewise, the other format for a horizontal parabola is x minus h with the 4p in front of that. And over here you have the y minus k quantity squared. So this is your vertical parabola and this is your horizontal parabola. And I think it's easier to just memorize these two formats like that. Okay? And if we do that and apply it to some of these problems, you'll see why that makes sense. All right, where do you want to start?
Number 3.
Okay.
Because I was told that I had to use the part of the quadratic equation to, or the quadratic formula to solve that, and I'm not quite sure how to go about doing that.
Well, it's not really true. You don't have to use the quadratic equation to solve this. What you have to do is put it into one of these two formats. Okay? In other words, if we can put it into either the vertical or the horizontal format, then we will know where our vertex is, where our focus is, where our directrix is, where our axis of symmetry is. I don't see anything them asking about directrix here.
Okay.
Is that on purpose? Have you not heard of Directrix?
Well, I know what it is and all
But they're
that
not
stuff, but
covering it in this page. Maybe they are on the next few pages.
yeah.
The best way to graph this, since they're not really talking about focus yet, let's work with the standard format, because we know how to graph the standard format, right? I mean, at this
I know.
Well, at this point, they're really not talking about focus and directrix, so there's no reason for us to use the 4P yet. What I need to do is to put this format into this format. If I can do that, then I will know H, I will know K, and I'll be able to figure out A. So how do we do it? Well, you complete the square. You don't use the quadratic formula. I'm not even sure I know how to do it using the quadratic formula, but I can complete the square. Well, how do you complete the square? Well, you isolate the x squared and the x term. So we make it like this. Put parentheses around it, leave room to complete the square, and put that -8 out here. Now, notice that I have not changed it. I haven't changed anything. In other words, these two things are the same, right?
Yeah.
Okay. Now let's complete the square. How do you complete the square?
You kind of rewrite it into two of the same and then multiply it out.
Specific way. We're only working inside the parentheses at the moment. What I'm going to do is take half of the coefficient of the x term, square it, and add it. Well, if I take half of 2, I get 1 or -1. Square that, becomes +1. I'm going to add it right there. Now, I've just changed it, right? I just added 1. So to balance it, on the same side of the equation, I'm subtracting another 1. Now, this top equation is the same as this rewritten equation down here. Okay? And the reason I completed the square was because once you've completed the square, you can now write this term as an x minus h, quantity squared, always. Whenever you complete the square, you're always able to write it as a linear term squared. These two numbers.
Where exactly did the 1 come from again?
The 1 was offsetting. Let me back up, because this is very important. Here's where I was at. I hadn't changed anything, okay?
Okay.
Dealing with the same equation. Only now, I'm going to add 1 to the right side of the equation, and such that I don't change anything, I have to subtract 1 to balance it.
Okay.
Now I'm still dealing with exactly the same thing I started with.
Okay.
The advantage is now I'm going to be able to write it in this format. I've got x minus 1 squared minus 9.
Okay.
Notice now I've got it in that exact format. Where's my vertex?
Vertex is 1, -9.
Correct. So I know how to graph it. And let's see, that's the only thing we have to do here, huh? Showing at least 3 points, the vertex should be 1 point, and label the vertex an axis of symmetry. Okay, let's try to draw this. Okay, the vertex, we're going to call that point 1 comma minus 9. Okay, I know which way does this thing open, up or down or right or left?
Up.
Okay, where am I going to find my other 2 points?
Other 2 points.
I got some choices.
Do the y-axis.
That's actually the easiest one. What's the y-intercept?
-8.
Correct. So we know that that parabola goes through -8. And what's another point? In other words, now I have quite a bit of the parabola. How do I get one other point?
You could get 2 -8 because it's a parabola and it's even on both sides.
In other words, I now have the axis of symmetry, which goes vertically through the vertex. And since that's an axis of symmetry, there has to be a point over there at 2 comma -8 that this thing is on. So there's my parabola. And I did it the easiest possible way. Now, 2 other points that you might have considered finding would be the X-Intercepts. Those are always pretty interesting points. How would I solve for the X-Intercept?
X-intercept.
What's true about y?
Can't you continue the parabola?
What's true about y when we're talking about the X-Intercept?
I don't know.
Well, look at these points that are on the x-axis that I put x's through here. What's the y value?
0.
That's key. That's huge. In other words, you have to solve for x-intercepts for the last 2 years and the next 3. So finding x-intercepts, it's vital to realize that the y is 0 on the x-intercept. Well, when we were looking at the y-intercept, what was true about x?
That x was 0.
There's a big thing. Always remember that. When you're talking y-intercept, plug in 0 for x. When you're talking x-intercept, plug in 0 for y. So let's say we wanted to find these 2 x-intercepts. Well, I'm going to plug in 0 for y and solve that. Actually solves pretty easily. I get 9 equals that. Take the square root of both sides, plus or minus 3 equals x minus 1. And then your x-intercepts are going to be plus 3 plus 1 and minus 3 plus 1. So your x-intercepts are going to be at 4 and minus 2. So this one here is minus 2, and this one here is at 4. So we could have found those 2 additional points if we'd have wanted. And I think you can see that actually finding the y-intercept was easier. And that's usually the case, although a lot of times they will always ask for the x-intercepts. It's not often that you get lobbed kind of a softball where they say, just find 3 points, even though any 3 points determine a parabola. It's like any 2 points determine a straight line, any 3 points determine a parabola. All right, where to next? Do you want to look at this format down here for number 4? Because that's a little, it's actually a little easier. Minus 1/2. What is that minus 1/2 going to tell us?
It's going to open downward.
Correct. And this is actually in x-intercept format.
Okay.
In other words, what are my x-intercepts? It's not in vertex format, so I can't immediately figure out where the vertex is, although once I got my x-intercepts, I'm going to be able to figure it out pretty easily. Where are my x-intercepts?
-3, 0, and then 5, 0.
I know the parabola opens down, so it must look something like that. Well, I've got 2 points. If I can figure out a vertex, I'll have my answer. That vertex is not, incidentally, on the y-axis. What's the next step? Very, very simple step.
I'm not sure.
Find the axis of symmetry. Part of the question says find the, where's the axis of symmetry? It's a vertical line. What is the equation of that line?
X equals 1.
Yeah, we know that the axis of symmetry runs through the vertex and is halfway between the x-intercepts, which is at 1. Okay, now I don't know that point yet, but I know a lot about that point. Its x-coordinate is 1. What's its y-coordinate? How do you
y-coordinate?
How are you going to get it?
I don't know.
Plug in 1 for x. Figure out what y is. Oh,
okay.
Once you have figured out the x-coordinate of the vertex, you can always get the y-coordinate of the vertex by plugging in the value you got for the x-coordinate. So if I plug in 1 for x here and there,
okay.
what do I get? I get minus 1/2 times 4 times minus 4.
Yeah.
Well, that looks like plus 8.
Okay.
And that answer makes sense. We're way up where we're at there. So we wouldn't want to come up with an answer of minus 8. We wouldn't look right. I mean, we would know it wouldn't be right.
Yeah.
So we've answered their question. That vertex is wrong right there. You got 1, 3. That's not it. It's 1, 8. Okay. Now, which one do you want to try next?
1 second.
In other words, you sent me 3 pages, and we only have about half of our session to go, a little bit more than half. So you may not want to go over every single one of these. You may know this subject well enough.
Can we just go over 6 and then switch to a different page for that?
I'm sorry I wasted so much time on the 4P. I didn't look at the problems. I just assumed that you were getting the same questions as all my other Algebra 2 students are, which is all about focus and directrix. Now, are some of the other pages dealing with focus and directrix? I think they are. I've seen these pages.
Number 11 is on a different page, but could we just get number 6 on this one down first?
Sure, absolutely. And notice these are all the form y equals x squared. We don't have any that are x equal y squared, which would be our horizontal ones. What format is this in?
Oh, sorry. I thought this was a different equation. This is just vertex. I can do this one.
Yeah, the vertex is at 1, -3, and once you have the vertex, it's pretty easy to find 2 other points.
Yeah.
Do it the same way you did it, find your y-intercept, and go from there. So, yeah, let's go on to stuff that's going to give you a little more trouble.
Okay.
Domain and range. Do you have any question about how to figure, once you've graphed it, is there any question at all as to how to figure your domain and range?
No.
The domain is always, on a quadratic, going to be all reals. Negative infinity to positive infinity. And the range is always going to be from either negative infinity to the peak, like number 1, or this point up to positive infinity, like number 2. And you've done
Okay.
that perfect, and it's greater than or equal to. That's correct. So, all right, let's leave this page and go to a different one here.
All right.
You tell me which one.
The next one will be the one with the graphs on the front of it.
Is that the top right one or the top left one? Top right one?
The top right.
Okay. All right, now let me blow this up just a little. Oh, man. I guess I have to push edit to make this plus minus thing come up. Yeah, this program. Where do you want to start here?
Could we do 25 and 28?
Okay. Now we're talking Directrix and focus on these. So my 5-minute speech wasn't wasted. You are going to have to do it. So 25, here's our graph. We can see that it's at the origin.
Yeah.
It's opening up. So what is approximately our equation going to be? If I use, are you comfortable with the 4p?
Yeah.
Okay. So is this, first of all, is it of the form y equal x squared, or is it the form x equal y squared?
Y equals x.
Okay. And now let's write the general format for that in terms of p.
All right. So the y equals
Always
1
remember
over
the
4p.
4p goes with the variable that is not being squared. So if you're going to start out the general format with the y on the left, start it out with 4p y
Okay.
equals x squared. Now, I didn't put in the h and the k because I can see that they're both 0, right?
Mm-hmm.
Okay.
Yeah.
What is p? Looking at the graph. In other words, the one thing I didn't add to this graph was this directrix down here at y equal minus 8.
Yeah.
So do you know what p is from that? P is up here somewhere.
Yeah, that's just positive 8.
Well, the distance from the vertex to the focus is always the same as the distance from the vertex to the directrix.
Mm-hmm.
So how far is it from the vertex to the directrix?
Negative. Just 8 units.
Okay, so what is P?
8 units up. Y equals 8.
The equation, not y equal 8. I know that P, this distance right here, is P. And that's P equals 8. Okay, now I just plug it in into this equation. So we have 32 y equals x squared, and that's the equation of that parabola.
Okay.
Pretty easy. In other words, once you know anything about it, 26, we're going to do exactly the same thing. Only we know that p is going to be negative. In other words, notice up here, p ended up being positive, right?
Yeah.
Even though the directrix was at negative 8, p was a positive 8. When you have a parabola that looks like this, well, p is always inside the parabola. So the next one, where it's also at the vertex, then p is going to be negative. In other words, this distance from there to there needs to be a negative number.
Yeah.
You have to go down into negative territory to find p. Well, how do we do that? We can do this one real quick. What's p first of all? Well, what's the directrix first of all? I'm going to erase that first one just to get it out of there so I have room to write. Okay.
All right.
It's still the equation we're going to use. That's still the general equation. but they're giving us in this one that y equals, what is that, 3/4? I'm having a hard time reading it.
That is y equals, well, this is, I wanted to do number 8, and that was
I don't
x equals -2.
I don't see 8 on here. Oh, 28.
Oh, 28, my bad.
Okay, well, still, there's only one last part of 26 to do.
Okay.
Let's draw the directrix in there. What's the equation of that? I can't read it in this copy you sent me. It's right.
Y equals 3/4.
Okay, so y equals 3/4 is the equation of the directrix, which makes p equal to what?
3/4.
-3/4. See why it's negative?
Yeah.
In other words, if the directrix is positive, it's above the x-axis. Well, we know p has to be below the x-axis. It's the same distance, so it's got to be -3/4. So the equation of 26 is going to be 4 times -3/4 y equal x squared, or -3y equal x squared. That's 26. Okay?
Okay.
Now let's look at some of these horizontal ones. You want to do 28?
Yeah.
Okay. What's the standard equation? In other words, the very first thing we notice about horizontals is it's no longer y and x squared, it's x equal y squared. And we're going to put the 4p in front of the x because it's the variable that's not being squared. And I can omit the h and the k because this vertex is also at the origin.
Okay.
Okay. Well, again, if I draw it, in this case, the directrix is a vertical line. And the equation of that line is x equal -2. Therefore, what is p? And
P equals 2 then.
okay, and what's the equation that they're looking for?
Y or x equals.
Hold on. Plug in 2 for p. Start your answer that way.
4 times 2 times x equals y squared.
That's the answer. You don't need to give it in terms of x equals something.
Okay.
If you have to, well then obviously x is equal to y squared over 8, but you don't need to do that. And in fact, it's actually a little better to leave it like this because that's the general format. In other words, when I look at it like this, if I'd have given you the equation instead of the picture, the graph, well, you can instantly tell that p is 2 because 4p has to be 8.
Okay.
Okay, so make sure you can go either way on these. Given a graph, you need to be able to come up with the equation. Given an equation, you need to be able to come up with the graph.
Okay.
Okay, and 2 makes sense for where the focus is. It's obviously in positive territory, so it's a +2 for p, not a -2. Next one do you want to look at?
Could we do one of the ones between 29 and 36?
Absolutely. Let's start with 29. So if our focus is at 3, 0, that actually tells us quite a bit. Now we need the equation of the directrix to tell us. The equation of the directrix is equal to that. Now, is that a horizontal? That's the very first thing you have to figure out is, are we looking at a horizontal or a vertical parabola? There's the directrix right there. That
This is
tells
going to be a
you whether it's horizontal, vertical, and which way it opens.
vertical, and it opens to the right.
It's not vertical. Remember, the directrix is always perpendicular. When you said opens to the right, you were right, but that's horizontal.
Okay.
Okay? Vertical is like this. Horizontal either opens to the right or the left.
Okay.
Now, they give us the focus right there at 3, 0. Well, that's pretty good. Can I write the equation with that much information? Here's the standard. What's the standard, first of all, using 4p designation?
X squared, or
Start with 4p. Always start with 4p. There you go. 4p, but it's not y. Remember, y equals x squared is the one you've been dealing with for 3 years, and that always opens either up or down.
Okay.
So when we're looking at horizontal ones, it has to be the reverse of this. It has to be x equal y squared.
Okay.
Okay? And I mean 4px equal y squared. Okay?
Mm-hmm.
So I know that 4px equals y squared is the general format for the parabola I'm looking at. Now, plug in p and you got your equation. It's real simple. That's one of the reasons they use this and not the one that has the A, is because if you use this one, boy, your answer is usually like a one-step answer in a lot of cases. So what's P?
That's going to be 3.
Positive or negative?
Positive.
Okay. So what's the equation going to be?
12x equals y squared.
That's it. Simple as that. So usually once you've figured out whether it's horizontal or vertical and what P is, then it's a piece of cake coming up with the equation. You just substitute P for what you have. How about another one? You can pick any one you want.
Let's do number 35.
Okay. Focus is at 0, 6 over 7.
Yeah.
Positive, okay. And the vertex is at 0, 0. And that's all the information they give us?
Yep.
Okay, so first of all, the focus is at 0, 6 over 7. The vertex is at there. What kind of parabola are we looking at? Horizontal, vertical, opening up, opening down?
Opening up, and that would be vertical.
Okay. So there's the thing. What's P equal to?
P is equal to 4 times 6 over 7.
No. P is always this distance right here.
Okay.
So it's 6/7. Right?
All right.
In other words, the coordinate there is 0, 6 over 7. So this distance here is 6/7. What's the standard equation for a vertical parabola?
What
do you always start with?
4p.
What comes next?
X.
What's the quadratic you've been working with for 3 years?
X equals y equals x squared.
That's the big difference. It's y equal x squared. So what goes next?
Y.
There's your general format. Now just plug in P of 6/7. So we got 4 times 6/7 y equal x squared. That's 24/7 y equal x squared, and that's your answer.
Okay.
In other words, the only thing they're asking for is write an equation of the parabola. They didn't say put it into y equals some form. They didn't say put it in vertex format. If they don't say put it in vertex format, well, then you can put it in this format here. In fact, that's probably the one you want to put it in. I would prefer this format to y equals 7/24 x squared. Okay, pick another one.
Let's see.
And I can bring up the next page if you need me to.
Sure.
You done with all of these? Looks like there might be some here that we would want to look at. Let's do at least 41.
Okay.
Okay. What is that, 1/8?
Yep.
All right. First of all, they're asking about the vertex, the focus, the directrix, and the axis of symmetry. Well, get started pretty easily. What's h and k? H is the x-coordinate of the vertex.
H is 3, k is 2.
Okay. All right, that solved a lot. What's the axis of symmetry? Is this a vertical or a horizontal?
It is vertical.
Okay. So it's going to do something like this, right?
Yeah.
What's the axis of symmetry? What's the equation of that line? The things they ask.
That x equals 2.
Yep. No, 3. H is 3. That point is 3. Okay, in other words, the coordinates on the vertex were 3, 2, right? So it's x equal 3. Okay. Now, the next step is really rather simple. The only thing we haven't answered, we've got the focus. No, we don't have the focus. We need the focus. We figured out the vertex and the axis of symmetry. The focus and the directrix. Well, I know the focus is somewhere there. What can I do with this equation to tell me the focus in really short time?
I'm not sure.
Multiply everything by 8. Well, move the 2 over. So start with moving the 2 over, like that.
Okay.
Now, notice that if I multiply everything by 8, I get this. The reason I multiplied everything by 8, because I wanted to get it into the P format, not the A format.
Okay.
It was given to me. That's the standard format for the A format right here. Whereas A is 1/8. But A doesn't, I guess you could just use the formula that A equals 1 over 4P or P equals 1 over 4A. But I'm a little hesitant not to have you do it this way. To me, especially, I mean, I know that they don't give you the whole course on conics in Algebra 2. They're just kind of introducing you to it. But even still, I think it's easiest to put this thing into the 4P format. Notice that I now have it in the perfect 4P format. It's 4P times y minus k equals x minus h quantity squared. Well, that's exactly what I'm looking at. So what's 4P equal to? There's
Wait, sorry, can you repeat that?
Yeah. I've got this equation into the 4P format. Okay, let me write the 4P format. The 4P format is 4P times the variable that is not being squared equals the variable that is being squared, like that.
Okay.
Okay, well, here's our equation that we've come up with. I still need,
All right.
what's P?
P is 2.
Yeah, in other words, these two equations look exactly the same, right?
Yeah.
Except 8 has to equal 4P. That's all you're doing, which means P is 2. Now that answers everything we need to know. So tell me the coordinates of the focus if P is 2.
Coordinates of the focus. Oh, then that'd just be -2.
No, remember that we're not at the origin on this one.
Okay.
Okay, the vertex is right there at the point 3, 2. And P is 2 units up from that. In other words, that little distance right there is 2 units. So what are the coordinates of the focus?
3, 4.
Yeah. Now, the last thing that we haven't done yet is told it the equation of the directrix. What is the equation of the directrix if P equals 2?
3, 0.
Yeah, no, it's the equation of a line. It's not a point.
Y equals 3.
No, y equals 0.
X equals 3.
Oh, hold on. That's not even the correct one. Yes, it is. If that's 2 units above, and this is at a y-coordinate of 2, then if I go 2 units down, the directrix is the x-axis.
Okay.
The equation of the x-axis is y equals 0. Always remember that when you're answering the you'll lose points if you don't do it. If you just say the directrix is at 0, definitely you're going to lose points. May not lose full credit, but you'll lose points. They want the equation of a line. It's just like when you ask for the vertex, you can't just say it's where x equals 3. You have to give an x and a y coordinate. And when you're asked about the focus, you have to give an x and a y coordinate. All right.
All right.
We got about 10 minutes. We got a time for at least one more. Want to do one of these more graphs up here, or you want to look at something on the other page, or we haven't done one of these kind of graphs.
Can we do number 11 on the last page?
Sure. Just have to figure out how to get rid of this. I've got to do it like this. The last page is the top left. Is that correct?
Yep.
All right. Wouldn't be a session if we didn't do a hard one, huh? So the vertex is somewhere along the x-axis. We don't know where. We don't know if it's there or there. I'm going to assume it's over here. Okay?
Yeah.
Just because we don't know that it's on the x-axis. The focus is at 0, 5. What does that tell us?
Is that what you plug into the thing?
Well, now, first of all, I was wrong. When it said the vertex was at 0, something, what that told me was that the vertex was on the y-axis, not the x-axis. I screwed up. In other words, if the vertex is somewhere here, say, then the coordinates would be 0, something, right?
Yeah.
Okay. So the vertex is on the y-axis, but we don't know where. We'll draw it like that. And they're telling us that the focus is at 0, 5. which is right there, which puts the directrix, we don't know yet. In other words, we still don't know what P is, right? Because we don't know where that vertex is. That vertex could be at y of 2, it could be a y of 3. So when they say use the distance formula, here's what they mean.
Okay.
There's one definition of a parabola that's very important. Okay, and that is the following. The distance from any point on the parabola to the focus is the same. In other words, let me draw a directrix here. I don't know where it's at, but it's somewhere there. Is the same as the distance to that directrix measured perpendicularly.
Yeah.
It doesn't matter where the point is. I can take a point way up here. That distance is the same as that distance. That is the definition of a parabola, actually. That's a better definition than it's just a quadratic, okay? So we know that's true, and that's the principle we're going to use here. Notice that they've drawn a directrix, and they've drawn a point on the directrix. Well, let's do it the way they're suggesting doing it. There's a point on the curve. What is that point? That point is x comma y. Okay? So I can say that the distance to that point is the same as the distance to that. Well, the distance to that point, what's the distance formula?
Y equals the square root of x2 minus x.
Distance equals?
Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared.
Okay, so in this case, x minus 0 squared plus y minus 5 squared.
Yeah.
So that's the distance from my focus to that point xy. Well, I also have, what is the distance from that vertically to the directrix?
Is that double?
No, it's the same. So it is, well, let's start off with that. It's the square root of x. The x doesn't change, right? In other words, the x coordinate of the directrix is the same as the x coordinate of this point, since I drew a vertical line. So can you see that x sub 2 minus x sub 1 is 0?
Okay.
In other words, we're looking for the distance of that line. Well, this point down here has a coordinate of x, the same x as this point up here because it's vertical, and some different y sub 2. Okay. Well, the distance is the difference in the x coordinates squared, that's 0, plus the difference in the y coordinates squared. Well, we know one y coordinate is 5. The other y coordinate we'll call y sub 2 minus 5 squared, and that's that distance.
Okay.
Now, we know those two distances are equal. So this distance here that was measured from this point to this point is the same as the distance below. So I'm just going to set them equal to each other. That's y sub 2 minus 5 quantity squared. And the distance is the same. So now I have this formula here.
Okay.
And thinking for a minute. There's something I'm not realizing here. I wonder why she put the red 0 next to that. Because what tells us that that vertex is at 0, 0? I don't know that it is. It's kind of the way she's drawn it, and the way she's drawn it here, see, that's the x-axis, and this is the directrix down here. If I know that this thing is drawn like this, well, now I can do a lot more solution. To be honest with you, I'm not sure I can solve it with the information given. I can't solve that equation. That's one equation and there's 3 variables in it. So this information that the vertex is at 0, 0 is vital. I need that to solve all of this. Now, how did she figure out? Now, I've got to go because I got a 4 o'clock. So I'm not going to be able to finish this problem, but I'm wondering if she just told you that that should have been 0, 0, and therefore you wrote it in. Because I don't know how I know that the vertex is at 0, 0. It doesn't have to be. It could be the picture I drew. In other words, the focus could be at 0, 5, and the vertex is at 0, something, but couldn't the vertex be at 0, 2? So it's almost like this was a misprint and she gave you additional information that I didn't incorporate into my solution, but you need to. Once you do that, then you can do this other. The crux of this thing is knowing that the distance from the focus to any point on the parabola is the same as the distance from that point to the directrix. Once you have that information, it should allow you to write the equation. Yeah, it will too. Remember, we're not actually solving for x and y, as all we're trying to do is come up with an equation of x and y. And this method will allow us to do that. All right. Mark, I will talk to you next time. Sounds like you're doing pretty good with this stuff. Keep it up.
All right.
All right. Have a good one. Talk to you next time. Bye-bye.